Let's start few problems based on binomial theorem. Now look at the first type of questions. See, remember I told you there are certain types of questions what you guys have to understand. This is the first type of question. See, expand the terms using binomial theorem. You just have to expand, nothing more, nothing else. Alright. See the first one, x by 3 plus 1 by x whole power 5. Remember what is the general term or general form of a binomial expansion or binomial theorem? You have, suppose if you have a plus b whole to the power of n, then we have nc naught a power n, nc1 a power n minus 1 into b, so on and so forth, ncn b power n. This is the general formula, isn't it? Now, in place of a and b, we have particular term, and in place of n, we have a particular number. In the sense, for the first question, what we are doing here, see, for the first one, a value is x by 3, b value is 1 by x, and the n value is 5. Correct? Now, if you substitute that here, then you're going to get 5c naught, the first one, into x by 3 whole power 5 plus 5c1 x by 3 whole to the power of 4, 5 minus 1 into 1 by x plus 5c2 x by 3 whole cube into 1 by x whole square plus 5c3 x by 3 whole square 1 by x whole cube plus 5c4 x by 3 into 1 by x whole power 4 plus 5c5 1 by x whole power 5. Now you need to simplify this. 5c naught is 1. 1 into x by 3 whole to the power of 5. That means here the answer is going to become x by 3 whole power 5 plus 5 into, see, you have x power 4 divided by x, which gives us x cube. So 5 into x to the power of 3 divided by 3 to the power of 4. The power of 3 is always 4 here. The next one, 5c2. 5c2 is 5 into 4 by 2 into 1. Correct? You have done this in the last chapter, in the previous chapter. So 5c2 is going to give us 10. Now you have 10 divided by 3 cube into x cube by x square, plus 5c3 is the same as 5c2. So that's 10 divided by 3 square into 1 by x plus 5 divided by 3 into 1 by x cube plus 1 by x to the power of 5. This becomes the final answer. See, no need of taking LCM or simplifying whatsoever. This is good enough. Okay, so this is going to be the final answer for the first question. Now, similarly, we are going to do the second one. All right. See, for the second one, you have x plus 1 by x whole to the power of 6. All right. Now, the same logic, we are going to apply the same thing. All right. So, first here, in place of a, we have x. In place of b, we have 1 by x. And in place of n, we have 6. So, you are going to get 6c naught to x to the power of 6 plus 6c1 x power 5 into 1 by x. Correct? 6c2 x square into 1 by x. Sorry, x to the power of 4. X power 4 into 1 by x whole square. My bad, sorry. Plus 6c3 x to the power of 3 into 1 by x whole to the power of 3. Remember, the value of a keeps on reducing, value of b keeps on increasing. Remember, we had done this in the last video. Plus 6c4 x to the power of 2 into 1 by x whole to the power of 4. 6c5 into x 1 by x whole power 5. 6c6 1 by x whole to the power of 6. Again, you need to further simplify. 6c naught is 1. 1 into this is going to give us x power 6 plus 6 into x to the power of 4 plus 6c2, which is 6 into 5 divided by 2 into 1, 15. 15x square, right? Now, next is you have 6c3, 6 into 5. So, what you can do, you can just make a small, calculation here. 6c3 is going to give us 6 into 5 into 4 divided by 3 into 2, which is going to give us 20, correct? So this is going to give us plus 20. X cube cancels. So it's just 20. 6c4. Again, 6c4 is the same as 6c2. Correct? And 6c2 is going to give us 15. 15 divided by x square or 15 into 1 by x square. Both of them are correct. Plus 6c5 is 6. 6 divided by x to the power of 4 plus 1 by x to the power of 6. See, this is going to give us the final answer. Fair enough? This is the answer for the second question. Now let's do the third one. See, for the third one, what we have, you have 2 by x minus x by 2 whole to the power of 5. Remember, there is a negative sign here and also the power is 5. Okay, now let me just recap the formula what you have. Suppose if you have a minus b whole to the power of n, then nc naught a power n, same thing, minus nc1 into a power n minus 1 into b plus, then minus, then plus, alternate plus and minus you will have, correct? Dot 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 minus 1 power n into ncn b power n. Isn't it? This is what we have. So in this case, a value is 2 by x, b value is x by 2, n value is 5. Substitute. So you're going to have 5c naught 2 by x whole power 5 minus 5c1 2 by x whole power 4 into x by 2, correct? Plus, alternate plus minus, right? 5c2 2 by x whole cube into x by 2 whole to the power of 2 minus 5c3 2 by x, 2 by x whole to the power of 2 into x by 2 whole cube plus 5c4 into 2 by x by 2 whole to the power of 4, right? Finally, minus 5c5 into x by 2 whole to the power of 5. Now we need to simplify this. So 5c naught is 1. So 1 into this one, 2 by x whole to the power of 5. So keep it as it is. Minus 5. See, you have 2 power 4 divided by 2 cube. So 5 into 2 cube into x by x power 4. So you can write this as divided by x cube plus 5c2. 5c2 is going to give us 5 into 4 by 2 into 1, which is 10. So 10 into 2 cube by 2 square is 2 into 2. X square by x cube is x. So divided by x. Fair enough? Minus 5c3 is the same as 5c2, which is again 10. 10, 2 square by 2 cube. So divided by 2 into x. X cube by x square, right? Remember to simplify this properly. Alright? Plus 5c4 is 5 into 2 by 2, 2 to the power of 4, which is 2 cube. So 5 by 2 cube into x cube minus x by 2 whole to the power of 5. Here you need to further simplify. So you will have 2 to the power of 5. You can do it or you can keep it as it is, but further simplification is generally required. Okay. 32 divided by x power 5 minus 5 into 8 is 40. 40 by x cube plus 20 by x minus 5x plus 5 by 8 x cube minus x power 5 by 32. This is going to be the final answer. Alright, so these are the first three basic type of problems. Okay, now further we are going to understand about the next type of problems. Alright, so we'll look into the next type of problems. See the next type of problem. Here, using binomial theorem, indicate which is larger, this one or this one. See, again, I'll tell you, using binomial theorem, they're asking you, prove that, okay, this is more or this is more, correct? This is the second type of problem, okay? Let's solve this one. It's quite easy, actually speaking. So here, the fourth one, see, using binomial theorem, so we'll do 1.1 whole power 10,000, right? So you have 1.1 whole power 10,000. Let's expand it. So we can write this as 1 plus 0.1 whole power 10,000. After that, what is 1 plus x whole power n? If you remember, nc naught plus nc1 into x plus nc2 into x square keeps on going, correct? Here we have a power of 10,000. You can't keep on doing till 10,000. We'll do for the first few terms, okay? So first is what? nc naught, which is 10,000 c naught plus 10,000 c1 into 0.1 plus 10,000 c2, so on and so forth. Now remember, the last term is going to become 10,000 c 10,000 into 0.1 power 10,000, correct? Well and good. Now what is 10,000 c naught? 1 plus 10,000, okay, this is 10,000 into 0.1 plus some term, so on and so forth. So you have 1 plus, what is 10,000 into 0.1? 1,000. 1,000 plus something. What is 1 plus 1,000? 1,001. So here only we got 1,001. What is the question? Which is larger, this one or 1,000? Now 1.1 power 10,000, we already got 1,001. So very clearly we can tell that 1,001, sorry, or you can also say 1.1 whole power 10,000 is greater than 1,000. Now similar type of questions can be asked to you. Very similar type of questions. 2.01 whole to the power of 10,000 and 1,002 or 1,005, something like this, which is greater. In all of these type of problems, you have to do it in the same way. Clear? Now let's do the next. See the fifth one. Find this value, hence or otherwise evaluate this one. So if you look at it, it's pretty much one and the same. So first what we'll do, we'll calculate what is the value of this one first. Then we'll apply the same, result what we get into the given problem. So here x plus 1 whole power 6. So you are going to have x plus 1 whole power 6. See, x plus 1 whole power 6 or x 1 plus x whole power 6. Both are one in the same, right? So we can write this. You can write the same thing or you can just write it as it is. Okay, it makes no difference anyway. So we can write this as nc naught x power 6, the first term, plus nc1 into x power 5 plus nc2 x power 4, nc3 x cube, nc2 x square, nc1 into x plus ncn. Sorry, Yeah, correct. So in this case, since it is a value of 6, wherever we have n, you can just put it as 6. Okay, wherever we have n. So the next thing is, see, right now I'm not putting value of n as 6. You guys will understand why. Because if you do it generally, it's much more easier. That's all. The next one is what? X minus 1. X minus 1 power 6. Again, in this case, you have nc naught into x to the power of 6. The first one. See, the second one is going to become minus. Correct? So we are going to have minus nc1 into x power 5 plus nc2 x power 4 minus nc3 x cube plus nc2 x square minus nc1 into x plus ncn. In this case, since n value is 6, minus 1 power 6 is plus 1. See, when you add these two together, these two gets cancelled, these two gets cancelled, these two gets cancelled. In the sense, 2 times, see, 6c naught. Now if I take a value of n as 6, 6c naught becomes 1 into this one. So 2 times x to the power of 6, first value, plus 6c2, because n value is 6. What is 6c2? 6 into 5 by 2 into 1, 15. So 2 times 15 into x to the power of 4 plus. So next you are going to have, so in this case I think it should be NC4. Okay, so this is 5 and keeps on going. So this should be 4. See, 6c4, 6c2 is one and the same. So 6c4 is going to give us same thing, 15 only, isn't it? Plus 15 into x square plus 6c6, and this should be 5. So 6c, what is 6c6? 1. So 1 into 1, so 1 plus 1 becomes 2. This is what we have, correct? Since this is the result, now what is the value? Otherwise or hence evaluate root 2 plus 1 whole power 6 plus root 2 minus 1 whole to the power of 6. In place of x we have root of 2, correct? Let's substitute x value as root 2 and find out the answer. If you take x value as root of 2, then see what you are going to get. 2 into root 2 whole power 6 plus 15 into root 2 whole power 4 plus 15 into root 2 whole square plus 2. So 2 into root of 2, which is going to give us 2 cube, correct? So you are going to get 2 cube plus 15 into 2 square plus 15 into 2 plus 2. 2 into 8 plus 4 into 15 is 60 plus 30 plus 2. 8 plus 2, 10. 10 plus 90 is 100. 100 into 2 is going to give us 200. So final answer for this question is going to be 200. Fair enough? So for this one, remember how to get the result. Once you got the result, then what you are going to do? You are going to apply that and get the answer for these two. So these are the next two types of problems. One is the comparison, which is greater, which is lesser. Okay, the next one is going to be this one. Find this one, hence find this one. Okay, so now we look into the next type of problem now. All right. See, this is the next type of problem. All right. See, evaluate using binomial theorem, 98 cube. Now, all of you have done this before in your school, that you were doing 100 minus 2 whole cube. The same logic. It's just that use binomial theorem. That's all. Very simple. All right. So what you have is 100. So the first one, 100 minus 2 whole cube. All right. So this is going to give us 3c naught into 100 cube minus, there is a negative sign, right? 3c1 into 100 square into 2 plus 3c2 into 100 into 2 square minus 3c3 into 2 cube. Okay, now expand. 100 cube minus 3 into 100 square into 2 plus 3 into 100 into 4 minus 8. Correct, this is the value. So you're going to get 1 followed by 2, 4, 6 zeros minus 2 into 3 is 6. 6 followed by 4 zeros plus 1200 minus 8. Correct? So this is going to give us 9411192. So this is going to give us this will be the final answer. All right. So this is the answer for 98 cube. Now let's do 102 whole power 5. Again the same logic, guys. There is no change at all. Okay, let's do the next one. See here what you have is 102. So let's make this as 100 plus 2 whole to the power of 5. Okay. So we are going to have 5c naught 100 to the power of 5, 5c1 100 power 4 into 2 plus 5c2 into 100 cube into 2 square plus 5c3 into 100 square into 2 cube plus 5c4 into 100 into 2 power 4 plus 5c5 into 2 power 5. It's a big one, yes, but it's quite an easy one to do. Okay, it's just monotonous. It's not very hard. 5c naught is 1, 100 to the power of 5. So 1 followed by 2, 4, 6, 8, 10. 10 zeros, 100 power 5. Plus 5 into 2 into 100 power 4 plus 5c2. 5c2 is going to give us 10. 10 into 100 cube into 4 plus 5c3 is the same as 5c2. That's 10. 10 into 8 into 100 square plus 5 into 16 into 100 plus 32. Okay, so it's going to be quite a big number. So you can write this as 10 to the power of 10, correct? Plus 5 into 2 is 10. 10 into 100 to the power of 4. 100 is 10 square. 10 square to the power of 4 is 10 to the power of 8. 10 power 8 into 10 is 10 power 9. Next, plus 4 into 10 to the power of 6 into 10 is 10 to the power of 7 plus 8 into 10 to the power of 4 into 10, 10 power 5 plus 8 into 10 to the power of 3 plus 32. Okay, so this one, the answer I'm going to write it here. Okay, so when you add all of them, you're going to get 110408088032. This is the answer for the second question. Okay, I know it's quite a big number, but this is the answer. Okay, now let's do the next one, the last one, 99 to the power of 5. All right, see for this one, what we can do, third one, 100 minus 1 to the power of 5. Correct? So this one, 5c naught into 100 power 5 minus 5c1 into 100 power 4, 5c2 into 100 cube minus 5c3 into 100 square plus 5c4 into 100 minus 5c5. Okay. So 10 power 10 minus 5 into 10 to the power of 8 plus, see, 10 power 6. 5c2 is how much? 10, right? So 10 into 10 power 6 is 10 power 7 minus 10 to the power of 4 into 10, 10 to the power of 5 plus 5 into 10 square minus 1. This is rather an easier one to solve, correct? So once you solve this one, you're going to get 95099000499. This is going to be the answer. Clear? So once you solve this 99 to the power of 5, this is going to be the answer. Now this is the next type of problem. See, so far we have solved 4 types, correct? First is the normal expansion. One more is the comparison. Third one is from this, find this one. And this is the fourth type where you're trying to evaluate using binomial theorem. Okay. Now, in the next one, you're going to understand what is a general term and how we are going to use that in finding different type of problems or finding the solution for different type of problems. We'll solve that and we'll see that in the next video.